students, good morning. As we have already started a new topic, indefinite integration. In our previous session, we have already learned what are the basics of the integration. Now, in continuation with this topic, today we will learn how we can do the integration by the substitution method. Now, our today topic is integrations by substitution method. Now, there are some working rules through which if we follow that rules, the integration is very easy there. Hello students, good morning. As we have already started a topic, indefinite integration. In our previous session, we have already discussed what are the basics of the integration. In continuation with this topic, today we will learn how we can find out the integration by a substitution method. Now, there are some working rules for the integration by the substitution method. Number 1, we will choose a new variable y is equal to given function. We will let the given function is equal to any other variable there. Then we will differentiate the given value with respect to x. Dy upon dx, y differentiation is dy upon dx is equal to g dash x. Then make the substitution in given integral to get a new integral in the term of variable y. Now we will get another integrals in the term of y there. Now we will integrate the new integral. Then at the end, we will replace the value of y to get the value of given integral in the term of x. Now, I am taking one example here, a very easy example. Integrate log x upon x with respect to x. Dx is there. Now, first of all, we will choose that which function we will let to the another variable. Now, we will choose the log x is equal to y because log x differentiation is 1 upon x and 1 upon x dx we will get the dy there. Now put log x is equal to y. It is the first step, another variable. Now we will differentiate this full equation with respect to x. So log x differentiation is 1 upon x and y differentiation is dy upon dx. Now by the cross multiplication, 1 upon x dx is equal to dy. That means 1 upon x dx is equal to dy and log x is equal to y there. We will put the value. We are having another integral there. Integrate y with respect to y. Integrate y dy there. Now we can integrate y with the simple formula. Y raised to power 1 is there. So it will be equal to y raised to power 1 plus 1 upon 1 plus 1 plus c, constant of integration. It will be equal to y square upon 2 plus c. At the starting, we put the value of log x as a y. At the end, we will again put the value of y there. It will be equal to log x square upon 2 plus c. Very simple example is there. Now, I am taking one more example in which t ratio is there. 1 upon x cos square 1 plus log x dx there. Now, whenever the t ratio is there, it's a very simple hint. We always put the angle. We always put the angle. We prefer to put this value there. Now, we will put the value 1 plus log x is equal to y, another variable y. We will differentiate the full equation with respect to x. One differentiation is 0. Log x differentiation is 1 upon x and y differentiation is dy upon dx. We cross multiply. It will be equal to 1 upon x dx is equal to dy. Now 1 upon x dx is equal to dy. We put the value there and cos square 1 plus log x is equal to y there. We put the value. It will be equal to 1 upon cos square is secant square y dy. Secant square y is the integration of tan y. So it will be equal to tan y plus c. Now we have to replace the y. Y is equal to 1 plus log x is there. We put the value there. 1 plus log x. Tan 1 plus log x plus c there. Now I am taking one more example. Now here cos x upon sin x plus under root of sin x, we have to integrate this value there. First of all, we will divide this sin x. Sin x is equal to under root sin x multiply under root sin x. We can write it as in this way. Now, I can take this full term and this term is there. Two terms are there. I can take under root sin x as a common factor there. So it will be equal to cos x divided by under root sin x in bracket. Under root sin x plus 1 is there in place of under root sin x. Now, we will put this full bracket under root sin x plus 1 to the another variable y there. We will differentiate the value. When we differentiate under root sin x, it will be equal to 1 upon 2 under root sin x. Now, it's a term of the differentiation of sin x. So, differentiation of sin x is cos x. And one differentiation is 0. Y differentiation is dy upon dx there. Now, we will cross multiply. We are having cos x upon under root of sin x dx is equal to this 2 will be multiplied to this side. 2 dy there. Now, we are having the full value there. Cos x under root sin x dx full value will be equal to 2 dy. And under root sin x plus 1 is equal to y there. We put the value. It will be equal to 2 outside because 2 is a constant term. Integrate of 1 upon y dy there. So integration of 1 upon y is log y. Now we will put the value there. 2 log y plus c is there. So y value is under root sin x plus 1. We put the value here. We will get the result there. 2 log mod of under root sin x plus 1 plus c. C is again the constant of integration. Now, I am taking one more example here in which first of all we will make the equation to put what value we have to put there. Sin x minus x cos x upon x plus sin x. We have to integrate with respect to x there. First of all, we will divide the numerator in such a way that we are having a differentiation of denominator in numerator. To make it, we will add and subtract x in the numerator. We will add and subtract x in the numerator. When we add and subtract the x there, it will be equal to x plus sin x minus x cos x and divided by denominator is same there, x into x plus sin x dx there. Now, we will divide the both equation there. One side we will take value x plus sin x upon x into x plus sin x. One equation is there, one fraction. The another side we will take the negative sign as a common here. It will be equal to x plus x cos x upon x into x plus sin x is there. Now, x plus sin x is cancelled. It will be equal to 1 upon x. Now, we are having two terms there, one term and the another term. And we have to integrate this full equation with respect to x. It becomes integrate of 1 upon x dx and the second is x and x common. X plus sin x 1 plus cos x with respect to x there. Now, in numerator, differentiation of the denominator is there. Now we will substitute the value. X plus sin x is equal to y. Now when we differentiate the value, it will be equal to x differentiation is 1 and cos x differentiation is sin x differentiation is cos x there. And y differentiation is dy upon dx there. Now we will cross multiply. 1 plus cos x dx is equal to dy. Now 1 plus cos x dx, here value is there. 1 plus cos x dx is dy. So we are having the value 1 upon y dy, and in their side 1 upon x dx term is there. So it's the simple integration, log x is there. Now minus integrate the second integral term. 1 upon y is again log y there. So log y is x plus sin x. We will put the value log x minus log x plus sin x plus c there. Now I am taking one more example. Evaluate. Integrate the tan cube 2x secant 2x dx there. Whenever tan case is there, convert it into the secant term. We are having one identity there. Secant square x minus tan square x is equal to 1. We always use this identity here. So that first of all, we will convert tan cube into tan square 2x into tan x. We divide cube into square and single power term. Secant 2x into dx is as it is there. Now, secant 2x, tan 2x, and at the place of tan square 2x, we will use this identity. Tan square 2x, it will be equal to secant square 2x minus 1. 1 will be shift to this side and tan square x will be shift to that side. So tan square 2x is equal to secant square 2x minus 1. Now secant 2x into tan 2x with respect to x. We have to integrate this value. Now we can easily put the value of secant 2x is equal to y, because differentiation of secant 2x is differentiation of secant x is secant x tan x. Now when the angle is 2x there, so multiply of 2 is also there. Secant 2x tan 2x into 2 is equal to dy upon dx. When we cross multiply, it will be equal to secant 2x tan 2x dx is equal to 1 by 2 dy there. Now we will put the value. This full statement are having a value 1 upon 2 dy. Now 1 upon 2 dy is there. Now secant square 2x means y. It will be equal to y square minus 1. Integrate with respect to y there. Now we can separate the integration term there. It will be equal to 1 by 2 y square dy minus 1 dy. Y square dy means y cube upon 3. Y integration is y there. Y cube upon 3 minus y upon 1. 1 upon 2 is as it is there plus c. Now y value is secant 2x. We can put the value. It will be equal to this 2 and 3 will be multiplied. 6 is there. 1 upon 6 secant 2x whole cube minus secant 2x upon 2 plus c. Now, I hope this concept is clear to you people. Integration by substitution method. Now you people are able to do the sum related to this topic. You will receive one link related to this topic. Go through that link also. Do your assignment. I hope you will do. Thank you.